Onorevoli colleghi, presentado le buone pratiche di ingegneria. Mi fanno un baffo. Mi fanno un baffo is an idiomatic expression about not caring. The origin, like mustaches, is ironic. In the old days, mustaches used to be this sign of strength and virility, but these days, it just means you're a dirty hipster. The same is true metaphorically of software development. It used to be about roughing it. It used to be about doing it the hard way. But we're smarter than that now. We have computers that are really, really fast, so let's use them correctly. We know that we should shave, but we don't. We keep this mustache. Why? Well, as software developers, we take on a lot of different hats, many roles day to day. And it can be tough to enforce best practices, especially in a team setting where you have to actually coordinate that with others. So, when you're shipping a feature, when you're just trying to get the thing out the door, it can be hard to care about things like unit tests and best practices. I could stand up here for the rest of my duration of the time and argue with you, prod, plead, beg that you shave your mustache, whatever that means for you in software development. But I don't think that would change anything, right? We're not going to, we've heard maybe a lot of that already. So instead, my talk is not telling you to get rid of your mustache. Instead, I'm going to give you a self-driving razor, which actually sounds kind of terrifying, but computers, it's software, it's not actually on your face. It's great. And the secret to all this, it's tooling and automation. And it's easier than a habit. What you have to do just once, you have to decide once to set this up, and then from now on, you no longer have the problem that it solves. It's great. I'm going to tell you about more than a dozen different tools. Some of them are brand new. They're for this talk in preparation for it, based on my experiences over the last couple of years consulting and working on different projects. But if you're going to take away just, let's say, two things from this talk, Swift format. That's the first tool I wanted to mention. A few months ago, there was a very lively discussion on the Swift forums. That kind of went everywhere and nowhere. It eventually got shelved in order to work more on Swift 5. But the tool exists, and it's officially in Apple's GitHub account. You can install it using those commands, and you can use it. It'll turn your ugly, weirdly formatted code into something beautiful. And if you don't like those default settings, it has a bunch of different configurable parameters that you can tweak. Set it up for your project to automatically format code, and you'll never argue about whitespace again. They say whitespace is like pollen. Some people doesn't affect them, other people are deathly allergic to it. Just get rid of it forever. Swift format is excellent, and it's ready to use today. If you don't like that, there are other formatters out there as well, including SwiftLint, but SwiftLint, that's not its main focus. That's the second tool I want to tell everybody emphatically, use it, start using it. It's one of the earliest third-party Swift developer tools out there, and y'all probably already know about it. How many of y'all are using SwiftLint in your projects? Yes, excellent, that's what I want to see. Okay, so I can't tell you anything new about SwiftLint, or maybe have you guys checked out the Analyze command? It's relatively new, maybe in the last couple years. What it does is it looks at the fully type-checked AST, so it requires the compiler log, that's that option in the command line. And it can check for things like use of explicit self or unused declarations and imports. It's very nice if you haven't touched your swift.yaml, swiftlint.yaml file in a while, if you haven't checked your configuration, give that a try. So use those two tools. Start with that. If there's nothing else you take away from the talk, please. That'll make your life so much better. However, the problem is you probably knew about the existence of these two tools or ones like them. But if you aren't already using them, why not? It might be because it's really confusing how you might incorporate them. I've come up with I found like 5 different ways to do it. First, and probably the most Apple-like, what they want you to do is to install an Xcode source extension from the App Store. Those don't exist, so that's not a real option. So what you instead could do is create a run script build phase to run SwiftLint or whatever your tool is every time you build your project. You might install that with Homebrew, or another way, actually it's kind of easier, is that through CocoaPods. If you already have the dependency as part of your project, it's already there to use. That's pretty cool. Or you might use Homebrew plus a git hook, a script that executes every time that you commit or push code. The problem is that those can't live as part of your repository. If you git clone, you have to, as a separate step, set up your git hooks, which just means you have to install a git hook manager, and it's just a whole nightmare. I haven't personally worked with those because I don't think many people know how to get those to work correctly. And then there's continuous integration. You can have a bot yell at you on GitHub, and that works pretty well too, but it costs money sometimes, and you might not be made of money. So of these options, each has their strengths, each one has their weaknesses. I think I've solved it though. I got this hybrid solution I want to pitch to you. Ready? Brew file plus build phases. Check this out. Brew file is this little known feature of Homebrew. You declare all of your dependencies, just like a gem file if you're a Rubyist. And you can do brew bundle, and it will install all of the pieces of software locally to, for what you need to build this project. Then you add build scripts first to run brew bundle every time it builds, but that should be a very fast operation if you've already done that. Then you do all of the commands that you do otherwise, assuming that you have them installed. It's pretty good. Try it out. Let me know what you think. So those are the tools. Automation, it's very helpful for keeping individual code files clean. But what if we want to tidy up our project? You know, one of the first things I do when I'm onboarding onto an unfamiliar code base is to just dig around and see what's in there, and often I'm very surprised. Projects can contain a lot of different things, whether it's code or code-like things like zip files and storyboards, or assets or colors. There are a lot of things that go into a project. For code in general, it's often helpful just to take a brief survey of everything in broad strokes, not even specific to Swift. And for that, I like this tool called Scancode. What it does is it looks through, checks the copyrights, looks for copyrights, looks for licenses and source files, and it will find all of this third-party code that you just sort of dumped in, all of the copy pasta from Stack Overflow, all of your embedded third-party dependencies, maybe some GPL stuff that you didn't know was in there. Take a moment, remove it, get it into a proper dependency management situation. It's great. And before I knew about Scancode, what I was actually doing was finding a lot of unused code using this other app or other tool called Periphery. This is an amazing tool. It will go through your project, look through the index. It will take the resulting graph of all the declarations and references. It will perform some different mutations on it to figure out what code is and is not being used, and it works really, really well. It'll find dead code in your project. You can, turn it up and down so it's just, type declarations like classes or structs down to, I think it can do parameters and methods, so that's pretty cool. Use that to identify different parts of your project that aren't actually being used. It's something that takes kind of a while, so you don't want that to be part of your build phase, but, on a weekly or monthly basis, let's say. So zips and storyboards, they're like code, except even more enigmatic. You have no idea what's inside of them. That's why tooling's really, really important, because you're not going to read that XML, let's be honest. IB tool, it's a built-in thing. You don't even have to install it if you already have Xcode. You can run it to find problems in your zibs and storyboards. And why this is helpful is that normally you only get notified of these in Xcode when you have those files opened. So let's say you're reviewing a PR and you're just building the app to see if it runs. Okay, great. You didn't notice that your teammate just introduced a bunch of auto layout issues. IB tool can do, help with that. Put it as part of your CI process. It'll catch it every time. And it pairs really nicely with this third-party tool called Ziblint. It audits for things like accessibility labels, ambiguous or misplaced views, use of non-named colors, and non-standard fonts. That's great. Also, a nice tool with that too is called IB Linter. Same idea, checks for things like auto layout constraints being relative to margins, which I like, I guess some people don't. Duplicates or ambiguous layouts, storyboard IDs with different view controller names, things like that. Best practices. Okay, next up, let's talk about assets really quick. There are some challenges with working with assets, as you know. You only know at runtime whether they're broken, and you find that out because you get a crash. Hopefully you get that in development, but sometimes we're not that lucky. Conversely, you don't really know what assets aren't being used anymore, which is really troubling if you have a penchant for just sort of dumping things in and taking what you need. And bonus, sometimes image name doesn't work as expected, but I can't help you with that one. The first two I can. Apple has to solve that bug. For this, I built a tool called XC Asset Lint. It'll help you find unused images in your project. So I was recently working on an app that had like a V1, and they built the V2 right on top of it. And they used feature flags, so it was like a seamless transition from one screen to the next. It was wonderful. They didn't have to do a whole rewrite. They just worked. They kept it working the whole time. That's really great. Problem is, they never got rid of the V1, so we had like megabytes and megabytes of stuff that we weren't using. This tool, or the predecessor to it, helped a lot, just identified everything we weren't using, and it gave us little warnings and errors anytime that we had a reference to, errors for images that are referenced but don't exist, and then warnings for anything that is in the asset catalog but not actually used in code. It's really cool. Another tool that can help, especially in coordination with that, is a Ruby gem called XCAssetsCop. Basically, you set policies for what things should be, and it will enforce that as part of your CI process. So you might, for example, have icons, a policy that says for every icon, they need to be a PDF, they need to be single scale, they need to be rendered as templates so that they'll adjust with tint color. And let's see, what's the other thing? Oh, right, asset name and file name agreement. You want to make sure those are named correctly. All those things, you can just set that with a simple YAML file. There's no such thing. A YAML file, and then it will check all of those every time that you run it. Okay, finally, colors. Subject should be near and dear to our hearts because, wait, how many of y'all recently implemented dark mode in your app? Okay, how many of you are still, like, that's the next thing you're doing? Okay. Really? Oh, I like dark mode a lot. So, typically, especially for larger organizations with actual design teams, there's a style guide. Maybe it's in a sketch file or a Figma file, and it defines a handful of officially sanctioned colors. The reality, though, is that instead what you find are just a bunch of variations of them that include the official colors, but also some other ones that developers decided that they thought would look good in the app, too. One project I worked on, we recently went through the process of converting to dark mode. We found over 150 different colors from a palette of 20. So that was like, that's over thousands of colors. Yeah, 150 variations. It was nuts. So two main culprits there. UI color initialization from hex codes. That's a killer because people love just putting random values in there. And then, that color picker and interface builder. Oh, did you know that has a hex picker in there now? I don't know when that was added to Mac OS, but there's one of the, I wish I could, I think it's the one with the slider. If you select the RGB sliders, they now have a box that you can copy paste the hex code for, which is great. Hopefully that saves somebody's life at some point. Certainly was my experience. So back to extracting tools, extracting colors. I created this tool called IB Color Tool, and it helps you make sense of all of those extra colors. It looks through the list of zibs and storyboard files that you pass into this tool, and it will list all of them in new line delimited form right to the terminal. And that pairs really well with other Unix tools like Unique and Sort. So you can find them. It produces both RGB hex values and UI color declarations. And you can use that to get a really good sense of all the colors that are in your black hole XML files that you use. So, given a list of colors, you could use a playground and some Swift code to group each color to the one closest to it, doing something like this. How do you get the distance between two colors? Well, simplest way is to use a Euclidean distance. So it's just like if you were, same as you were doing for like point x comma y to x2 comma y2. You know, that kind of thing. It's what you learned in geometry class. It's just the sum of square pairwise differences between the red, green, and blue components. In the process of doing this, I learned a lot about colors just because this is kind of boring and I wanted to just dive into something else. If you'll allow me this digression, it's just a quick thing. We're going to talk about colorimetry for a second. So RGB color space, where we represent colors using red, green, and blue components, you can imagine that to be a cube, right? You have 3 dimensions and they go between some, 0 and some value, 1, 255, whatever it is. That's the RGB color space. However, cubes are a really bad way of modeling color because the human eye perceives color more like this, right? There's a lot more green in there, especially at the top. The easiest way to demonstrate this, and also maybe check how good the presenter is. So this is RGB. This is a gradient between green and blue in stepwise form. You'll notice on the left-hand side, it's really hard to distinguish between those greens, but those are distinct green values. If we were to instead show, that's RGB, let's move it to a different color space. This is a perceptually uniform color space called lab, L-A-B. That's great. You can definitely tell, maybe those last two are a little bit tough, but you can definitely tell that those are all separate colors. The problem with perceptual color spaces, as that weird shape might indicate, is that it's a little bit harder to calculate the distance between colors. Did you know, though, it's built into core graphics. This logic is in there. So you can do perceptual color comparisons between two CG color refs. Okay, another challenge you might face if you don't have that design team and that style guide is, given a list of colors, how do you group them, right? So you might think, okay, clustering. I've heard of something called k-means clustering. That's a very popular algorithm for this. The problem is you need to define what that k value is, how many centroids you're organizing around ahead of time. That's tough because you don't know, like let's say you have 100 different gray values, true story, and you want to determine how many distinct ones there really are in there. It's just a guess, and you don't really know how good that guess is. So instead, if you want a clustering algorithm, there's this kind of obscure one called dbScan. And instead of defining how many centroids you have as a result, you define an epsilon, the minimum value that differentiates between two different clusters. And what it does is it calculates the distances between each different point, and if it finds a cluster nearby, it'll combine with that if it's close enough. If there are two clusters that are nearby, if they're close enough, they'll combine. So eventually they sort of categorize. I didn't find an implementation in Swift for this, so I created one in case you ever need to do something like this, whether it's for colors or otherwise. And you can also, it's making use of that fun new Swift feature, the static callable thing. So you can have a structure that's called as a function. It's pretty neat. So the basic idea is that you have these colors, which might actually, in retrospect, be difficult to tell right there, but there are some there. It'll automatically categorize them in these two categories, and it'll say, there we go, cluster 1, cluster 2. It's up to you to figure out what to name those, but there are algorithms for that too. You could even take the second, another step and say, okay, considering macadam ellipses, which are a way to model, spaces of colors that aren't distinguishable by the human eye, you could only group colors that are within that value, but that's, an exercise for the reader. So that's my digression. Colors are really interesting, by the way. Let's talk about build tools some more, I guess. That's what's in the box of our Xcode project. But let's talk about the box itself, the Xcode project. What is an Xcode project? It's a miserable pile of secrets, but enough talk, have at you. It's a bundle of a bunch of arcane files, some of which you maybe work with on a day-to-day basis, some of which might surprise you. But the main one, this project file, this project.pbx, it's awful. It's a mess of UUIDs. My advice to you, get rid of it. Throw it away. Throw away your Xcode project file. This is my advice to you today. First, externalize all of the configuration you have in your project. Everything that you have in that Xcode project build settings, take those out. Have a shared one that defines the shared settings for your whole project, and then have different ones for your configurations. Debug, beta, app store, whatever you want. To help you with this, I built a tool called Xcode which lets you list out, you pass in the project file, it'll list out all of the settings, it'll even annotate them with documentation if I could find that. So that's cool. You pass in your project file and you get back this Xcconfig file style declaration. It's just key equals value. It's great. It doesn't do any, it doesn't affect your project file, it just lists it out. But that's a feature to be developed soon. Once you've done this, you can then incorporate a project called Xcprojectlint to ensure that all project configuration is externalized in those Xcconfig files. It'll also check for things like no project or file containing white space specifications, like your indentation width, that all source code files are members of a target. They're not just randomly in your project, that they exist on disk, that they mirror the file system structure. That one's a bit pedantic, but some people like to keep things organized, that groups are organized in alphabetical order, and that no groups are empty. Those are some of the checks that you can enable with Xcprojectlint. But why even bother having a project file in the first place when you can just generate it, right? Instead of dealing with this artifact directly, why not create a specification, again, a YAML file, and then point this tool, Xcode Gen, to generate your project file for you, right? So you can point it at your directory of Swift files, and it'll create groups according to what directories are inside of that, because that's what you wanted in the first place, right? It'll have them in alphabetical order. And the next time you have that merge conflict, just trash it and rewrite it, regenerate it. Though, if you don't take that further step, because I understand that's kind of scary to get rid of your project file, here's another tool that can help you out. It's a Python script called merge_pbx. And what that does is that you can configure it with Git, and it will, instead of diffing it like it was a plain text file, it'll do some transformations, basically give it the AST representation so that it can do more sophisticated diffing. So instead of choking on groups being renamed and reordered at the same time, it'll be able to resolve that automatically. So that's a really nice tool. So to install, first you have to declare it as an available merge tool, and then you configure your project to use it for PBX proj files. That's pretty cool. Okay, now that you have a clean project, how do you keep the bugs away? Well, obviously the answer is tests. We all know that. But once again, saying write tests, write more tests, that's not really actionable advice. How do you know what to write a test for? How do you know when you're done writing tests? Well, these are things that tools can also help us to do. When tests are run, Xcode generates XCOV coverage files that track how many times each line of code in your project was run in the process of executing a test. And now, as of Xcode 10, I think, you can now see that in the editor next to the code you write, so that'll keep you accountable. If you want to quickly scan through and see which functions in your model are maybe a bit under-tested, this is a great way to surmise that. So that's in Xcode. If you want to get a sense of how your coverage is outside of Xcode, there's a project called XCPerfect. It's a Ruby gem. And you run it, you pass in the JSON representation of your Xcode coverage, and it'll generate this nice bar graph. This is the same thing that we saw. There's a different representation of the Xcode UI we just saw. So the only challenge that I saw in that was figuring out where the derived data folder is. And I know what you're saying. We all know derived data is at the user library, Xcode developer, whatever that is. But the problem is that each project, each target has this 28-character random signature at the end. And I know in my heart of hearts as an engineer that that's there so that there's no naming collision. But there's a part of me that thinks that maybe Apple just want to make my life hard. I want to make your life easy. So I created a tool called XC-derived data. It's basically that script up there, those 4 Unix commands in something that you can install with Homebrew. So you pass that. You can pass whatever Xcode build arguments you have, and it'll point you to the built Xcode XC-derived data folder for that project. Now, with code coverage, I want to stress, 100% code coverage is not what you're going for. You don't win an award for that. In fact, that's just a fool's errand. But even if you did achieve 100% code coverage, there are limitations to that. There's only so much that you can interrogate yourself. And that's why there's something called fuzz testing. Now, fuzz testing is a lesser-known, kind of obscure quality assurance technique, at least obscure within the context of iOS, that is used to discover coding errors, especially for C projects. There's a whole, I think Google Zero, their whole thing is fuzzing in giant C code bases and finding all of these memory allocation errors that you otherwise wouldn't even notice were there. So essentially, you're creating a program to test your program with random inputs. And we're talking random inputs on the order of millions per second. We're just maxing out your CPU, sending as much garbage data to your program. It's a powerful technique. It doesn't work for iOS apps. You can't just send a bunch of data to an iOS app. I don't even know what that means. But it does work if you have a parser or something like that that's taking input and dealing with it in a known way. This is how you do it. So first, you download a development build of Swift from the swift.org website. Just use that alternative keychain, and then that gives you access to libfuzzer. If you annotate a function with this @cdecal thing, LLVM fuzzer test one input, it's awful. And you have that method signature in Swift. It'll automatically find that when you run it with the libfuzzer sanitizer on it. So for example, if you had a JSON parser, you could create a fuzz test like this. That's the basic gist of how you convert between that and the foundation data types you're familiar with. However, for JSON and other parsers where the information is very structured, you'd need to specify a dictionary. So here's like a text file with some of the characters that you might expect to see in a JSON file. You pass that in and it'll generate a bunch of random, sometimes valid, sometimes invalid JSON. In my tests against, I'm not going to say which one, open source JSON library, was able to crash it within a couple seconds. I looked at what actually crashed it. It was a bunch of opening curly braces, so something to do with the Stack Overflow. It's great. So again, not totally applicable for iOS apps because that's not what we're writing when we're writing apps. But what might be applicable and kind of related is the idea of UI fuzz testing. And you manually do that sometimes when you're just like tapping on things. You're just like, whatever, I just want to see if this thing breaks. But you can automate that too. I found a CocoaPod called Swift Monkey and has a companion library called Swift Monkey UI. And rather than telling you more about it, I can just show you a little screen recording that it has. Yeah, you get it. So it's simulating random touches, random gestures, and then eventually maybe your app crashes, or I don't know if that might be the GIF repeating, but hopefully your app doesn't crash. So writing testable code requires us to modularize. We should take the similar approach when we're creating our UI. You start with fundamental components, and you create functional units and combine them all together for each screen in your app. Most apps are a single target and maybe a handful of extensions, but what I want to advocate is that you create more targets. Don't be afraid to make targets. If you have like a junk drawer of utilities that are extensions on Foundation, create a framework for that and test that separately. Create a UI framework for all of the UI elements, all of the custom buttons and views that you put into your different view controllers. Put that in a separate framework. Benefit from clear division of responsibilities. You can test them separately. And then similarly, some teams use storyboards like this. They have a single storyboard file, and they just have their entire app laid out. As nice as that looks, that's not going to work very well. Instead, obviously, you split that out into different storyboard references. I will say, notice how like those branches look suspiciously like tiny little apps. This is just a weird harebrained prediction, but like, wouldn't it be weird in a couple years if Apple provides a way to sort of run those different apps separately, load them separately using on-demand resources? That doesn't exist yet in iOS, but there's similar things in Android, and if you do like a web app, there are provisions for that. So I don't know, maybe Apple will catch up in a couple years. That'd be kind of cool. Anyway, so all of that is a segue to the next topic, component testing. So you have your app with a scene and a view controller. How about if you link that view controller to a UI framework, something just for your custom UI in your app? You build and test that separately in isolation from the rest of your project. Here's another advantage, though. Let's say you have a subclass of UI button, configurable border around it. If you have an interface, it doesn't look like much if you set the custom class, just looks like a UI button. If you use IB designable and IB inspectable, though, you can configure it in Storyboard, preview it live, seeing what it'll actually look like. By extracting that into a separate UI framework, that can build separately and not have to depend on the rest of the project. So when you're generating that preview, what you're building is just that UI framework. So that's a way to really speed that up. But who cares about storyboards anyway, right? Because Swift UI is here. That's obviously what you're using for real app development today. Well, the good news is that we can actually use Swift UI with our existing UI kit-based projects. You know, everybody has the new Catalina installed, right? Because we install that on the first day, or it automatically installs for us. With the latest version of Xcode, if you target iOS 13 as a development target, you can use Swift UI previews for all your views. So you can do that for screens. You can use groups to get parallel versions of the same view in different configurations. You might use that to live preview dark and light mode, or your localizations, or dynamic types. You can get all of those in a row. You can use those for view controllers, and you take advantage of the new instantiate initial view controller methods from iOS 13. And while previews are helpful for development, they're not a replacement for real test coverage, for integration tests. The combinatorics are astonishing. So like, let's say we had light and dark mode, and we had 3 dynamic type settings, which is kind of low. You have 3 size classes for the SE, 11, and Max, unless you want to have an app that goes to US, Italy, and Japan. Just those factors, you're talking about 54 combinations of apps. we need a plan. We need to make a plan. And fortunately, Xcode 11 test plans make it very easy for you to test without recompiling, along with test bundles. These work together to test things really, really fast. And you can set tests, like let's say you have a plan that runs every time part of a commit. It's just your focused unit tests. Maybe you have ones that are run as preconditions on tagged releases that test accessibility and localization. Or let's say it runs as a precondition of tagged releases, let's say every night, right? Every time that you have a new localization file that's uploaded from your translators. Maybe you create a new, run that test just to test localization. You can use the XC attachment and snapshot features that are in Xcode XC test framework and get those results from those tests. The screenshots show up as well as property lists that annotate the frames of each view and the accessibility, or I think, it's just the string contents of each label in there, so you can check the localization as well. And if you keep screenshots every day as you run these tests, you can see, okay, here's the screenshot from this screen. Oh, it started to be a bug starting on Tuesday. So that's when you can test like what change actually broke the build in a way that wouldn't normally break other tests. So there's one unfortunate change in Xcode 11 that you should be aware of. It used to be something like this whenever you got these results back. This is now what it looks like in Xcode 11 when it's running the tests. It's a very clear separation. You have attachments and diagnostics inside this bundle. However, in Xcode 11, after you finish running it, turns into this, which again, I think that's a sign that Cupertino hates us. Fortunately, I found a tool called XC Parse. You pass that in, and it will extract your screenshots from those XC result bundles. Super nice. I will say, as a personal note, snapshots can be really helpful as regression tests. But one thing is that they're just nice to have around. Posterity. Everything that we do in software is really fleeting. I remember like the first app that I worked on, it was an app called Gowalla. It was a social networking app, and it was beautiful. I kept my life in there. That was my, how I remember those years of my life. I used it constantly. And then the app got acquired by Facebook and just turned into nothing. I don't know where that data is anymore. The only screenshots I have of the app are whatever bloggers decided to cover it over the couple years I was working on it. That's it. I don't have any other things to show for my work. We work in a digital medium. It's less than ephemeral. So take these screenshots and put them somewhere so that you have something to show for it. Anyway, so to recap, we wear a lot of different hats as software developers, and it makes it very easy to get lazy about our practices, to wear a mustache. Using tooling and automation, we can unpack our code base, we can ward off bugs, and we can battle test all of our components. We can modularize and test in isolation and do it reproducibly. And these tools allow us to do it in a way that you just set it up once, it'll automatically keep us honest. So that's best practices. All you have to do is do it once. That's all. Here's a list of tools. I'll post that to the Slack for later. Check them out. Thank you so much.